Welcome to my very long titled talk. The summary is we're going to be talking about Kotlin Multiplatform incorporating native SDKs. I am Kevin Galligan. I'm a partner at a company called TouchLab, technical partner. I've been doing Android since before the G1 and some other things. I also have to change this slide. I'm a Kotlin GDE. I keep forgetting to mention that. And they're going to make me upset. I'm going to get in trouble with the GDEs. TouchLab, we've been around since 2010-ish, mostly mobile dev shop. We work with some cool folks. We've made some cool things. We are 100% focused on Kotlin multi-platform at this point. Not all of these are Kotlin multi-platform, but some are. I want to say a special thanks to Square. We are partnered with them for a few years now, and they help us essentially to do some cool open source stuff and some cool, not quite open source stuff that you may see soon, but definitely thanks to them, they're helping the community quite a bit. So KMP lets you write code, like common code that can be compiled to different platforms, and we all kind of know that. Again, unless you haven't done any, then you don't, in which case, you know, hopefully you get something out of this. But a lot of times you want to incorporate native code into your Kotlin code, and it's all specific to the platform that it's on, right? So we want to pull the stuff in. I often pitch talks that are wild in scope. I made a new rule for myself, which is I'm going to write the talk and then pitch it. And then I wind up doing this because it's like crazy and I can never fit into a conference length talk. So I'm going to try to stay more high level. I was not going to do this. There are parts where I do this. But don't worry, we'll get through them quick. So anyway, sometimes you want to talk to the native platforms, and that's what we're going to talk about today. And we're going to focus in on native mobile, because that's mostly what I do. It's mostly what the killer app for KMP is, and this is a mobile conference, so that makes sense. We're also not going to talk about JNI, because there's plenty of stuff out there about JNI. Not a huge fan, and you occasionally have to touch it. But for the most part, with KMP, you're trying to incorporate an iOS thing into an already existing like Android thing, right? So that's usually what we're into. So today we're going to cover tell Kotlin about the native code. That's step one. We're going to talk about linking that code with an Xcode framework and API design. We're going to touch on that a bit. The first thing I want to say is you should try to go simple first. And by that I mean don't do any of this. Make interfaces and then pass in the code from Swift directly is a much easier way to kind of get these things done if you need to, especially if you're making an app, not a library, right? So the benefits are essentially you don't need C interop. There's no weird linking, no extra binary size. The downside is it's not easily testable. If you're passing in Swift at the start of an app, you can't really test that with Kotlin's testing facility easily. It's impractical for complex situations, and it's bad for libraries. But as the always example I put out is analytics, right? So most analytic libraries they have a function for an event that's a string that takes a map of other data, and every analytics library basically has this pattern. I mean, it differs, of course, but generally speaking. So you make this interface in Kotlin, and then we have a function essentially that when we start the app, we pass in some stuff from iOS. And on the iOS side, you essentially just do this, right? You make a class that implements the interface. This thing, analytics, is Firebase analytics, so it's real easy to call. And we just pass it in on start, right? And if you do that, you're done. You don't need any C interop. You don't need any of this crazy stuff. It's really easy to do. We do this a lot in our app development. In other places in the app, you'll see it like where you're calling a function. So you pass in a callback, right? You wouldn't do C interop for this. It would be crazy in a lot of cases. You have to be careful, of course, with a narrow scoped thing about memory leaks and Swift and whatever. But still, it's a common pattern, and we do that a lot. So if you're not going to do that, then we have this thing called C interop. And I avoided C interop mostly, and I've been doing Kotlin multi-platform since 2017. It's a big, scary topic. It's hard to set up. It tends to be brittle in your setup. Things go wrong. It can be difficult to debug, or at least until you get used to it, right? What C interop does is it allows you to call C-like code, L-I-K-E. So you get C, Objective-C. You can call that. And then you can also call some Swift, but only Swift that is callable from Objective-C, which is sort of a special thing, which we won't go into too much today. And you can call C++, but only if it exposes a C interface with extern C. So if it doesn't, you have to write your own C++ interface, which is way out of scope for today's talk, so we won't talk about that at all. Anyway, so C interop does this. You have headers, and you run C interop on those headers, and it produces a Kotlin interface that you can call that can talk to those native things. I think it's important to point out for Android developers, and we run into this a lot with new team members, CNROP doesn't do anything for the binary. It just generates the header. It just looks at the header and says, this is how you would call this if it were available. And it's important to understand that that's all CNROP does. So the binary question mark, you have to find that, you have to make it available to the linker, and that we'll talk about in a bit. So CNROP at its core is actually quite simple. You have to provide 3 basic things, which is the package you want this to be generated in, the language you're using, which is Objective-C, often could be C, and the headers that you want to ingest. And that's kind of basically it. The rest of this is like Gradle minutia that you can find in tutorials or other examples, which we don't need to bore you with in a conference talk. Just assume that you have to wire some things and tell it where the headers are. But essentially, this is all you're doing with CNROP. And it's pretty straightforward conceptually. The only bit of minutia I'll throw out there is a tip. CNROP doesn't generate Kotlin. It generates Kotlin binary representation that the IDE understands, the compiler understands, but you probably will not. So if you want to debug what's happening with CNROP, you can pass this in. It'll generate Kotlin. I've never got that Kotlin to then work and be compiled. I have to turn this off when you're done debugging. But it's just something to know if you get into this. It's quite useful, because otherwise you're kind of flying blind. And the IDE will stabilize, I'm sure, over time, but sometimes it can be difficult to import the CNROP code. It doesn't always come in, even though it'll compile, which is a common Kotlin multi-platform complaint. That was a lot of alliteration. Anyway, so this is the thing, and we have to figure out where that binary is. So anyway, where do you get these header files from? And there are multiple options that we found in the various things we've been doing over the years. So the simplest thing is just put them in your repo, right? If they're in your repo, you know where they are. You don't have to deal with anything special. Immediately, people are like, well, what happens if the version changes? And I'm like, well, it depends what you're doing. So we write the driver underneath SQLite. It's called SQLiter on the native side, and we just put the header for SQLite in the repo, because SQLite, although versions do change, it's one of the most stable APIs you'll find. They don't change anything that already exists. So we don't really need to update this. We don't have to worry about external things unless we add new features. So it's right in there. You can do script downloads. I've seen this for other SQLite implementations. Like they'll have a version, they'll download everything, they'll extract it. It's a lot of Gradle, boilerplate, but that works too. We haven't really done that. I have this other thing which is called, I call it truncated headers. I think this is another thing that Android folks are not really used to header files as much, generally speaking. The header file is not everything that's in this binary. It's only the things that you care about that it might be in some binary in the future. So you can take a big SDK and then take it in just the little things you need. If they're relatively stable, then you don't have to worry about versioning. So a concrete example of this is we do a Crashlytics integration. Crashlytics changes over time. The API changes over time. But the parts we care about are like this much out of their total thing. So all we want to do is generate enough CNROP to talk to that thing. It coincidentally doesn't change much, the part that we're talking about, so we put them directly in our repo. And there's a subtle thing, which the binary that's generated for the CNROP is not free. So you have to be a little bit careful, especially with libraries. Somewhere in here I have a slide that basically says, by the way, a lot of this is recency and we've been working on libraries. So if you're just working on an app, some of these things are not as relevant, just FYI. But with libraries, definitely, like if you're adding binary you don't need to add, you're going to hear about it. It's not good. But it's not good for your consumer libraries either. If you're doing non-consumer apps, it's like, well, whatever. So CocoaPods dependency. This is what I call the hammer approach, which is you essentially just in your Kotlin say, we depend on this CocoaPods thing. And it pulls in the header, it'll pull in the binary, it kind of wires everything together when it works. It does not always work. I like this for apps. It does add a lot of time sometimes to the compiling, but it's good for apps. It is much less good for libraries, again, because now you're kind of like stuck with versions. You kind of get a weird situation. Plus, it generates CNROP for everything in that library. So if you're doing Firebase Analytics and Crashlytics and Firebase Core, like you got a lot of binary that's getting generated that isn't something you're ever going to call. So I haven't done tests on how much that adds, but there's a little thing, I've done a lot of size tests for Kotlin multi-platform. So if you're generating like Objective-C interfaces to the framework and you're not calling them, there's binary that's like essentially Objective-C adapters at runtime that gets added, and they be significant. So CampKit is our big public example. I changes some classes to internal, and that cut 20% of the total binary off. And that's all I did. So it's one of those things you have to be careful about, especially at scale. So there's a lot of docs on Kotlin, CocoaPods and Kotlin. So I'm not going to go deep in the weeds, but it is, if it works and you're not building a library, I would say this is definitely like the option you should probably start with. It will look like this. This is what gets generated unless you change the package and stuff like that. This is the analytics example if you did it with C interop. So I can't find a good reason to do it that way. Just pass it in again. So it makes projects kind of weird. You used to not be able to run your Kotlin tests. Now apparently you kind of can. Like things have changed a lot in the last couple of versions. I will say I'm not entirely aware of all the changes, so we're kind of learning as we go. But it does carry dependencies along in your pod spec. I'm worried about the version, like if you get stuck with versions, if you have a large app, your iOS team is not really going to want to have your Kotlin library dictating versions of various things. So that's one of my reluctance. I don't like the way that it's all tied together in a hard fashion, but these things they're in flux. If you actually run into an issue and you want something to change, like reach out. Like we talk with JetBrains a lot. Their team is very responsive when they can be. So you can actually get a lot of things changed if you want it. Anyway, there's this other thing. Somebody built a Carthage importer. And what I like about this conceptually is Carthage is meant to be very lightweight. It doesn't tie everything together. So you can just import some native stuff. It kind of does all the parts you would need, but it doesn't gunk up your dependency tree. The downside is I hate Carthage. Like I super hate Carthage because we had to implement it for one of our clients. And like I, at the time, was the most advanced in this part of the stack. So I had to scrub in essentially and figure this out. And it was like weeks. And you just run into all these issues that are just left like unfixed. And I got the impression that between CocoaPods and Swift Package Manager, Carthage is kind of having a tough time. So it's not that I dislike the developers. They seem really great. But the thing itself is kind of rough. And I think it's going to struggle in the future. But that exists. You want to try it out. We have not tried it out yet. It's on my endless list of things to try out. SPM, not yet. But like everything SPM and KMP, it's coming, I'm sure. I don't know if JetBrains is going to do it. We might do something with that. We're working on the other side, like producing better outputs for SPM, because the client that I spent 2 weeks trying to get Carthage to work, like, here you go, and then the first user internally was like, oh, we're actually switching to SPM. I'm like, cool. So all that Carthage work was right out the window. All right, anyway, that's how you get headers in various techniques. Linking. So this is the part like, okay, where is your binary? Back on this slide, right? We have a lot of folks, when we hire, we're hiring, by the way, we're distributed, not even just the US anymore. So please reach out. No, when people join, they're usually Android developers. Obviously, Kotlin tends to attract more Android people. And usually that means you haven't done a lot of linking. So it's kind of scary, this big board of all these options, you don't know where to start. And if you do something wrong, it might go real bad. I would imagine this board would. On the flip side, once you kind of get into it, there's not like a ton you got to understand. It's like once you get the basics down, it is glue, and you're going to have like flags flying around and passed into compilers and all this kind of crazy stuff. But it's not too bad. Here's my quick primer. If you see this, and you notice a little LD, and then another thing that says undefined symbols for blah, 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 that's a linker issue. That's all you need to know. No, it is very important, and people you have to understand when that's happening. And if you want to figure out what's going on, it'll tell you what's missing, and then it'll tell you where it's referenced from, and you usually recognize like, oh, that's that weird library I put in there. Apparently, it's not linked up correctly. So, the linking basics, as far as KMP is concerned, you make a framework, and then you want that framework with its symbols to be inside your binary app somehow. Static frameworks are simpler, I would argue. They just kind of do this. So the compiler, the linker, sorry, when you're building your Xcode, your iOS app will just take the symbols directly out of the static and pull them in. To me, it's conceptually simpler. It tends to, there's arguments about faster load time potentially because more dynamic frameworks can be slower. It will do a better job, I would argue, in dead code elimination because if you take the whole dynamic, I don't think it can, or it really doesn't always. Anyway, that's static. We generally prefer static when we're building things. I can't give you a good reason to use dynamic generally, although we have some structural reasons with new tools. We're trying to figure out static is still behind, but that's a different story. Dynamic is this. So it takes the whole thing and shoves it in there. Again, if you read blog posts, apparently it can have slower load times for apps, yada, yada, yada. I'm not going to really go deep on arguing which way is the best, but I will say this. So when we are building these frameworks, Kotlin multi-platform, and I guess linkers in general, if you're building static, you don't need to tell it anything about the binary at the time you build it. You just got to give it the headers, and it assumes that later you'll link and everything will work out. And that tends to be much easier for configuration. Dynamic, for whatever reason, I'm not sure why, you have to provide the binary at the time of build. And that became, like, at least, I don't know if it's just a Kotlin thing. This is one of the things we were trying to figure out before the talk. And I didn't get a good, satisfactory answer, so follow us on Twitter or whatever. Hopefully we're going to have a better blog post about all this. But it makes it difficult because you need to make that binary available at Kotlin build time. And that becomes difficult if you want to like manage all your dependencies in the iOS thing, like as you normally would. So, and again, like I was in the middle of writing this talk. I'm like, oh, this is all from the perspective of writing libraries. Like if you're building an app, you can just do CocoaPods and don't worry about this. A lot of my work is libraries. So libraries makes it a lot more complex. And my recency bias as I was writing this talk was like, all right, that was all specific to that one library. So keep that in mind. Anyway, so what was this? Yeah, this is what I want to do with Kermit. And Kermit is the logging library we have Crashlytics in. And I want to have the header defined in the library, and I want iOS app to control the actual integration with Firebase, whatever version you want to do. But Dynamic won't let you do that. This is the thing we kept running into. Thaddeus is here. This will look familiar. And again, if we're looking, try to like figure out what it means. Undefined symbols is pointing at Crashlytics. That's the problem. So again, we didn't figure out a good definitive answer before this talk. I was going to say the workaround is just in your app, put the CocoaPods thing, but then that had more linker errors. So if you've ever seen this episode of The Simpsons, Marge is teaching piano, and she's just going to stay one lesson ahead of the student. So that's what I'm going to do for this answer. So if you're really concerned about that, check back in. So CocoaPods have the header and the binary, and you stuff it in there. And assuming CocoaPods works and you don't run into the linking issues we ran into, that should be straightforward. If you have code, just header and binary code, or sorry, not binary code, C or M code, M is generally Objective-C, you have to get that into your app. The C in our app is straightforward. We talked about that. Getting binary code into your app is a little more difficult. So you can do Clang, and you have to configure Clang, and there may be a lot of architectures, and you got to get all those things right. Once you get it set up, it's not too bad, but it can be a little difficult. And then shoving it into a klib versus just having it available on the path, there's a lot of like kind of configuration stuff you have to do. We also do this sometimes, where especially if it's static, you can just say, C_app's going to run here, and then in the app, we're just going to let like Xcode figure out how to build our C files. That can be difficult sometimes with testing, so you have to like avoid having any part of the thing that's special in your test. It's a long story. Anyway, it can be a little tricky, but it's a nice workaround to do that. We also built this thing. It's a library called cklib, and what it does is essentially we pulled a bunch of stuff out of the Kotlin compiler that builds C code, and we have the settings in the same code there. And it'll build your C code and then shove it into your klib so you can distribute it as a library and not worry about anything. The downside is I absolutely promise I will not respond to support tickets unless I'm very bored. We are not supporting this library because most of the tickets are like not about Kotlin that we've been getting, and also the library is kind of duct tapey and weird. But it does work. So if you need to distribute binary code in your klibs and not worry about configuration downstream, this will work. Just don't expect, I may not respond if you ask questions. You can find links to that. It's the library. We are using it in, again, Cash App's doing a weird thing. But you should check that out because it's kind of neat. They're distributing Kotlin.js across the wire and having it talk to native Kotlin libraries on the phone, so you can do updates outside of the App Store. That's using cklib and some other weird stuff in it. And this is another Kermit thing, so you can check that out. Anyway, check that out. We have some deep dive linking links if you want to read more about linking. I don't know if you do, but take a look at those. It is important if you're going to get into this to really understand how that works. Otherwise, you're going to struggle wiring up anything that's like more than trivial. So testing is kind of a special discussion that, again, was also in flux when I was doing this talk. So the Kotlin compiler like makes a special executable to run your tests. It doesn't actually incorporate the framework itself necessarily, which I probably should have changed the slide a bit to make that more clear. If you're doing CocoaPods or some code, things should kind of work together as expected, assuming you get all the configuration set up correctly for your tests. Firebase and something like that is where it gets weird, because there's no easy way to like download Firebase that's going to be run on like a Mac OS executable. So some of these external integrations can be very difficult for testing. We do one thing in Kermit where we have a stub binary that satisfies the linker, although it does nothing. So you can put that in there and run your test as long as you don't try to run that part of the test. But frankly, why would you run Crashlytics in your test? I don't know. So that will work. And also, if you can somehow avoid calling anything that touches that code, like the compiler can like dead code eliminate that stuff. So it's something to think about. Again, it is very specific to this kind of case where we're doing Firebase or some platform integration. But I will say the most likely thing you're going to do is a platform integration with an existing SDK. So it can become something that can be a little difficult if you're trying to do that in your app. Blah, blah, blah. I have to read my slide notes. Oh, yeah. So anyway, we had a workaround for this. And then, again, it was the thing that we couldn't figure out. So stay tuned. Hopefully we get that figured out. But just stay one lesson ahead, and everything will be great. I'm unfortunately not one lesson ahead today. So some thoughts on API design. And I will say this. So when you come to it, there's kind of an uncanny valley if you have an Android and an iOS SDK already defined. Like they look like they're basically the same code, and they should do the same thing. But they're both designed by humans, right? So like, you know, they look the same, but you're not gonna be able to automatically like run something. Like people ask, like we have an automatic like generator for common code, and it just doesn't work that way. So you're gonna have to write that yourself. In cases where we're taking actual C code and importing it on both sides, it is conceivable that you could write something that will generate the JNI, and you could write something that will generate the iOS side and do that automatically. However, I would say, from a likelihood that someone's going to write that anytime soon, probably not very high. I actually had like a talk, this is the generating thing. I was talking to the Objctive-C founder, and he was like asking the same thing, and I'm like, how many people need to convert J to Objc to talk to Kotlin multi-platform automatically? You can fit all of them in a small party bus globally. So I don't think anyone's going to bother to write that automatic generator. So for now, this is you. You have to write this thing regardless of how you do it. So the rules are kind of difficult to have hard rules. I would say it kind of depends like for everything, which is usual in computer science. Russell's going to give a talk tomorrow. We both say the same thing every time, like don't use expect actual anywhere, use interfaces everywhere, and then I immediately break the rules. So I would say don't default to expect actual. I think everyone that comes to KMP, they see this new structure, and they're like, oh, quick, cool. We use that everywhere. But it's actually less flexible and very difficult to test. It's really not like good to use accessibly, and generally interfaces are better. So going back to the analytics, if we did expect class this, you can only have one implementation per platform, and you can't swap out your tested implementation. So it's very inflexible. If you do this, we do this a lot where we'll have an interface and then a expect factory function. So this gets you what you need without the inflexibility of the other structure, right? So this is the folder structure for Kermit, and Kermit has many targets because logging is kind of a platform-specific thing. And it would be daunting to try to have an expect actual for this whole thing. But we solved that with this platform log writer, which is a factory function. So if you don't know what to do when you load Kermit, you just call that, and it'll pick the right one. But you don't need to do that, especially in testing. So that's what I would say. Don't use expect actual. But then in Crashlytics, it's like, well, you don't need it for testing. You're not going to run this in tests. And so I just made an expect actual because there's only two platforms that we care about. I could have done it this way. It was just a game time decision. I can't tell you exactly why I picked one or the other, but there was like no benefit to picking the other one. So again, it kind of depends. Use your best judgment. You'll find yourself breaking the rules fairly often. I will say service objects and small object graphs, interfaces and delegates are fine, and I usually default to them. And even if you didn't want to, like, the C interface can be like very ugly to use, so you kind of want to hide it and like make it more Kotlin friendly. Anyway, when you get into parent-child relationships and larger graphs, this can get a little bit ugly using interfaces with delegates. So in this example, let's imagine we had this thing, order and products and suppliers, and you can imagine calling different things. It's going to return a bunch of different stuff. It's like data objects. With delegates, you kind of wind up with this weird like pattern where everything's got a delegate and they're all kind of wired in, and it's kind of brittle and strange to manage. And also like allocations at runtime that you probably don't want to do because everything needs an extra allocation for the wrapper. So there's this thing called you can do an actual side of an expect actual with a type alias. And what that is, when you define your expect class, and if you get the definition exactly correct, this is from several years ago, this slide. This is stately. Fun question to myself is, would I design stately the same now as I did in 2018? And I don't know. But this is what it is. Anyway, so there's the expect class. On the JVM, we can just do this because the types match exactly. And we can just have this thing exactly match that expect, and it goes away during compilation. It just kind of boils off. But the actuals need to match exactly, and the other side will not. So on iOS, we wind up with this thing where we have the delegate, as the diagram was showing you, and then all the implementations of the methods. So that brings us to this thing I call platform affinity. So when you're designing a library, let's say, and we did this a lot in the beginning because we wanted Android developers to adopt libraries without feeling like they were going to add anything in their library that was going to negatively impact whatever, yada yada. So what happens is, essentially we make the whole common code look like the Android side, and then everything on the iOS side becomes sort of an Android-y implementation of the same thing. And it's not something I would necessarily recommend as much as I did back then, because the iOS side is already kind of the stepchild platform of KMP, and a lot of our work now is trying to make that more developer-friendly. And type aliases can be brittle. In this case, there were like protected methods that we wanted to have in the type alias, but that doesn't work because the visibility doesn't work. So you could not use those classes at all. And this slide is from a few years ago. The bug is still open. It's 5 years now. I don't think it's ever going to be fixed. So type alias is interesting, but it can be difficult to use in a practical situation. And if you've got more than just Android and iOS, you wind up with like one platform that's the obvious default, and everything else is kind of this weird mishmash. So anyway, the parallel delegates. That's what I was talking about there. Now, I did talk about this in a talk a few years ago, and it was used to interesting effect. If you have this problem, here was like a way that we got around it, which was we had expect classes that were empty, and then everything in them was an extension function. And the reason we did that was because you could type alias everything because there's no types to match, so they all match. And then you don't wind up having to have a delegate, but you can implement each method in a separate way for each platform. So it avoids like that the big chain of delegates and all that kind of stuff. This is what iOS looked like. This is what, oh yeah, I was just pointing out some things in these slides. Apparently, copy paste from an old talk. I forget exactly what I was saying, but you get the point. Sorry. So you get this document snapshot thing. Again, expect, open that thing. The actuals are just type aliases, but there's no types. So it becomes real easy. And then on the Android side, similar implementation. So instead of this, where you get the one platform and everything else kind of mimics it, you wind up with something more like this, which is arguably a better design if you're going to try to like match the two platforms equally. And it goes from this back to this, which is nice. Again, this is rare, and again, this is recency because I'm talking about mostly library development. In your app, this may not be an issue. But if you do run into it, it is an interesting technique that we've been using to some success. So here's a talk I gave a couple years ago about it, 2019, so several years ago. The pandemic's like a memory hole. And then we have this thing, definitely not supported, the Firestore KMP. We built a whole Firestore implementation using that. There's one thing that I was hoping for, inline classes, which are now confusingly called value classes, not to be confused with value types. They would solve this because, I don't know if you know anything about inline classes, but you have essentially one value that's held by this thing, but at runtime it doesn't actually implement the wrapper. It doesn't instantiate the wrapper. It just calls that thing inside it. Unfortunately, as far as I can tell, you can't make an expect class without that value, and that defeats the purpose. So I don't know. This is another thing where I'll get back to you because we have to experiment with it more. That would be real neat, and it would kind of get around the problem that we're trying to fix with the other structure. But anyway, getting back to it though, like the API kind of almost designs itself. Like there's not a lot of tricks to it. Like if you're importing something that already exists, you're essentially going to be mapping the same thing, and then it kind of is. We found it to be iterative. Like you build the API in common Kotlin. There's a couple things you got to support that maybe aren't on one platform or the other. So you develop these little weird edge cases. But for the most part, it's not so bad. It is good if you can also add some Kotlin isms on top of these native platforms, which is the talk I'm going to talk about in Berlin, which is how to design SDKs from these things. But I would say one thing that I find people fighting initially, and then they kind of grudgingly come to it. It is platform-specific init. And at this point, SDKs and apps, I just assume you're going to have to do a platform-specific init. And what I mean by that is when the app starts, you got to call into some platform-specific code to do some things, right? As an Android developer, what do you think the chances are you're going to have a significant library that doesn't need context at some point? 0. So it's much better to pass in to start on the particular platforms. And again, you can pass in functions, you can pass in interfaces, and then after that, you can do the other calls in the common code. So I would say if there's anything to take away from this talk, just plan on having platform-specific initialization in a lot of these things. And we kind of bring it back around to start simple first. Just pass it in if you can, because the rest of this gets a little nasty. But if you need to do it, obviously, it can be very powerful too, but just prepare for a lot of config and stuff. But you know, it was a lot, but it's not all that bad once you get the basics of it, especially understanding how the native linking and all that kind of stuff works, and how to debug it when it goes wrong. It's not too bad. And the Slack channel, the Kotlin Slack channel, is very friendly. Please reach out, and we're happy to answer questions. At Touch Lab right now, we are doing some interesting things. And since this crowd is a crowd that's likely done some KMP, I'm putting out a call to action, which is we're focusing a lot on building tools that are focused on bigger teams, on making the iOS developer experience more approachable, I would say. Doing some weird Swift code generation explorations now, and some other things that aren't exactly public. If you are working on KMP in production, or you're evaluating and you decided against it, or you have a larger team that's trying to figure out how to everyone work together happily and not hate this, please reach out. I would love to talk to you. And this is not a pitch for the company. Not that if you want, we're a consulting company, but mostly I just want to talk to people and figure out what they're doing. And these are the best ways to get a hold of me. So please, please, please reach out if you just want to talk shop. And I'd love to hear what kind of troubles you're facing and how you're getting around them or not. And it's going to be very valuable for us and hopefully the community. That's it. That was my weird dive into native integrations. I hope that wasn't too much weird detail. Meandering. We are definitely hiring. We're still aggressively trying to hire. So if you are interested in doing KMP, if you're interested in learning this weird stuff, we're doing libraries, we're doing like first things that anyone's ever seen, kind of weird stuff. Please reach out.